Welcome, stargazers. Might you at any point trust it? Picture a heavenly event so huge that it creates shaded areas on Earth, apparent even without trying to hide. That is the scene we may be near the very edge of seeing. In the Orion constellation, the star Betelgeuse is acting strangely, indicating a looming cosmic explosion that will illuminate our sky more than ever. However, when will Betelgeuse go supernova, and what will it look like according to researchers? What secrets could this heavenly event uncover? Join us as we plunge deep into the details of what's actually the deal with Betelgeuse and the effect it could have on Earth and maybe for the whole nearby planetary system. Found around 650 light-years from Earth in the Orion constellation, Betelgeuse isn't just any normal star. It's a red supergiant, quite possibly one of the most glowing stars known to us, shining with a brilliance over 100,000 times that of our Sun. But why does this red giant matter so much to us? Well, Betelgeuse stands out for its brilliance but also for its history and importance in human culture. Named after the Arabic expression Yalal, which means the hand of Orion, Betelgeuse has been noticed and documented by ancient civilizations for hundreds of years. It has been a guide for travelers and a mark of wonder for astronomers, with its ruddy shade distinguishing it from other stars in the Orion constellation. Can you imagine a single star overshadowing our whole solar system? To give some perspective on the sheer immensity of Betelgeuse, if it replaced our Sun, its edges would extend all the way to Jupiter. How could a single star achieve such huge proportions? At 10 million years old, it's significantly younger than our 5-billion-year-old Sun. However, Betelgeuse's enormous size means it burns through its material much faster, predicting a shorter life expectancy than that of other stars. Now, this celestial behemoth, traversing a volume big enough to contain more than 1 billion of our suns, is approaching its final cycle. When stars of such size reach their twilight years, they don't just disappear. They exit with an extravagant flare, a cosmic explosion blast that is beyond human understanding in terms of its energy and brilliance. Such an event has the potential to dominate a whole galaxy, creating shaded areas of brilliance across vast distances. The last time Earth saw a supernova blast this close was in 1964, sometime before the development of modern telescopes. This event, known as the Kepler supernova, was the last supernova to be seen in our Milky Way galaxy with the naked eye. It remained visible for more than 1.5 years, more brilliant than any other star in the night sky and even visible during the day for several weeks. What secrets do these heavenly remnants uncover for us? Ancient records from various human civilizations, including Chinese and European astronomers, recorded the appearance of this new star. Interestingly, remnants of this blast, in the form of an expanding debris cloud, can still be observed today with complex telescopes, giving us insights into the violent ends of massive stars. Supernovae have been rare for observers on Earth, but imagine for a second a stellar explosion so intense that it rivals the brilliance of a full moon, casting shadows on Earth at night and even being visible during daylight. The radiation from such an event could charge our atmosphere, possibly affecting satellite operations and even the climate. Betelgeuse, with its erratic dimming patterns, suggests it may be preparing for just such a grand display. Could we be on the edge of witnessing one of the universe's most dramatic events? Just recently, astronomers made a surprising discovery. Between October 2019 and mid-2023, Betelgeuse underwent a remarkable transformation that drew the attention of astronomers and skywatchers worldwide. Known as the Great Dimming, the star's brilliance, which had been stable for centuries, began to decline significantly. This sudden change was so noticeable that even casual stargazers saw it. When comparing Betelgeuse to other stars in the Orion constellation, it was clear that something unusual was happening. This means that we're not only hundreds of years away from seeing its supernova blast, but maybe only a few decades, or even less. By April 2023, cosmic observations reported that Betelgeuse had returned to its normal brightness levels, leading many to believe that the period of anomaly had ended. In a stunning twist, the following months saw Betelgeuse's brightness intensifying by an astounding half. Such prominent variances, while typical of variable stars, were surprising for a star like Betelgeuse, which had mostly shown predictable luminosity cycles. The sudden and extreme surge in its brilliance pushed the star back into the spotlight, igniting discussions about its future. But what caused this sudden change in brightness? Why did Betelgeuse, one of the most familiar stars in our night sky, suddenly throw a divine curveball? Stars are not just shimmering spots in our night sky. They are dynamic entities with life cycles, behaviors, and mysteries of their own. For some celestial bodies, periodic brightness variations can be expected, akin to the rhythm of Earth's seasons. Throughout its stellar lifetime, Betelgeuse has kept a relatively consistent 400-day brightness cycle. However, with the Great Dimming, it appeared to defy its established behavior, testing our understanding of cosmic phenomena. Now, you may be wondering, are we on the verge of a cosmic revelation? While the exact reasons behind Betelgeuse's abnormalities are still under investigation, a compelling hypothesis has emerged. This hypothesis, focusing on stellar activity and mass ejection, presents an intriguing scenario. Picture Betelgeuse as a massive celestial volcano quietly ejecting and expelling vast amounts of its material into space. Recent observations from the Hubble Space Telescope revealed that Betelgeuse had recently expelled a tremendous amount of surface material into the universe. This ejection, a monumental event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our moon. Such events can result in the formation of a thick dust cloud around the star, affecting its apparent brightness and temporarily making it more challenging to observe. Then, as this dust began to scatter or was driven away by the star's radiation pressure, the veil lifted. This could explain its subsequent return to normal brightness levels. One way or another, these new events suggest a star that's far from done. Astonishing to us, many speculate that Betelgeuse may be approaching the twilight of its life, with a supernova event, a sudden burst of energy that can eclipse an entire galaxy in an instant, on the horizon. This phenomenon occurs when there is a sudden change in the star's core. Such changes can arise if a star absorbs too much matter from a neighboring star or, in Betelgeuse's case, from the exhaustion of its nuclear fuel, which overflows its mass into the core, setting the stage for a catastrophic collapse. But what drives a massive star like Betelgeuse to its end? Born from the gravitational collapse of gas within molecular clouds, stars like Betelgeuse begin their journey by consuming hydrogen in their cores. This initial phase, known as the main sequence phase, lasts for billions of years and forms the foundation of a star's life. As stars near the end of their hydrogen supply, they expand, adopting new energy sources. In the case of Betelgeuse, as the hydrogen depletes, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence stage to the helium burning phase is marked by the star's evolution into a red giant. Over time, as helium reserves decrease, the star undergoes further expansion and shifts into other burning stages, each marked by the fusion of progressively heavier elements. The larger the star, the faster these transitions occur, given the immense gravitational forces at play. Then comes the climax, when iron begins to form in the core. Unlike lighter elements, iron doesn't release energy when fused, so the energy produced is insufficient to counteract the star's own crushing gravity. The star inflates in size, eventually collapsing and triggering a massive rebound explosion, resulting in the explosive force of a supernova. So, is Betelgeuse nearing the edge of a catastrophic end or simply biding its time? Ongoing research by Japan's Tohoku University suggests that the star may currently be in its carbon-burning stage. Lead scientist Hoku believes the core could collapse within a few years once its carbon reserves are exhausted. But not all researchers agree. Studies from Hungary's Konkoly Observatory hypothesize that Betelgeuse is still in its earlier helium-burning stage. The one thing all scientists seem to agree on, despite these debates, is that Betelgeuse is set to become the Milky Way's next supernova. But pinning down the timing of this event remains a vast guessing game, with bets ranging from just a few years to 100,000 years. Amid these scientific discussions and speculations about Betelgeuse's future, one fact remains unchallenged: the very nature of our observations. When we look up at the starry field, there's a subtle paradox we often overlook. This paradox lies in the very concept of time and light. In our vast universe, Stars and celestial bodies are so distant that their light takes an immense amount of time to reach our eyes. For example, the speed of light, while an impressive 186,282 miles per second, still has its limitations. Consequently, the light from distant stars and galaxies takes time to traverse the vastness of space before it reaches us. Looking at Betelgeuse, you're actually seeing a spectacle from 650 years in the past. To put that in context, when this light left on its journey toward Earth, the Renaissance was just unfolding and adventurers like Marco Polo were embarking on their expeditions. The reality is that the Betelgeuse you see today could be a star that has already exploded, and we're only just seeing its light reach us now. However, astronomers still hope that the star will live long enough for us to witness the event in real-time. We look forward to the possibility of witnessing a supernova from Betelgeuse. It's crucial to recognize that the sheer magnitude of such an event would be transformative. The explosion of a star like Betelgeuse would release an unimaginable amount of energy. A supernova can briefly outshine an entire galaxy, sending shockwaves through space and radiating cosmic rays in all directions. If this supernova occurs within our galactic neighborhood, the effects could ripple across the entire solar system. However, it's unlikely to pose a direct threat to Earth, as Betelgeuse is located about 650 light-years away, far enough that the explosive force wouldn't destroy our planet. Still, the radiation from such an event could have some interesting side effects. For example, the high-energy particles emitted by the supernova could interact with Earth's atmosphere, possibly altering the chemistry of the air and affecting the ozone layer. Some scientists speculate that a burst of cosmic rays could impact satellite technology, leading to increased radiation levels for astronauts and even disturbing communication systems. While Earth might not face immediate harm, such an event could provide us with valuable scientific data, offering new insights into the fundamental processes of stellar evolution, particle physics, and cosmic ray interactions. The idea of witnessing Betelgeuse's supernova also opens up a deeper discussion about the vastness of time and space. The fact that the light we're seeing from the star is 650 years old makes us aware of how much has changed in the universe while this information has traveled across space. It emphasizes how stargazing connects us not just to the stars themselves, but to the history of the universe. What we see when we gaze up at Betelgeuse is a snapshot of a distant past. The star may already have exploded, or it might be on the verge of doing so. But the light we see is a messenger, telling the tale of what was happening hundreds of years ago. Looking ahead, astronomers will continue to closely monitor Betelgeuse's behavior, keeping a vigilant eye on any further fluctuations in its brightness or signs of impending collapse. New technological advancements in telescopes and other observational tools may provide even clearer insights into the star's condition and help refine our predictions about when the supernova will occur. Additionally, future space missions may be able to provide more direct data from the vicinity of the star, offering a richer understanding of its final stages. In the end, the fate of Betelgeuse is a reminder of the ever-changing nature of the universe. Stars are born, live, and die, and their explosive ends leave behind a legacy that can influence the very fabric of the cosmos. While the exact timing of Betelgeuse's supernova remains uncertain, the anticipation of such an extraordinary event fills us with awe and curiosity about the mysteries of the universe. We are, after all, part of the same cosmic journey, our existence intertwined with the stars we observe. And so, as we continue to study and watch Betelgeuse, we are reminded of our place in the universe. We are stargazers, seeking to understand the grand tapestry of the cosmos, not just to peer into the past, but to witness the unfolding of one of nature's most spectacular phenomena. The explosion of Betelgeuse will undoubtedly be one of the most dazzling and awe-inspiring events ever seen by humanity. And whether it happens tomorrow or in thousands of years, it will forever be a symbol of the boundless mysteries that await us in the cosmos. Perhaps, one day, future generations will look back at this moment in history, recalling how the great red giant, Betelgeuse, lit up the night sky, offering us a glimpse into the cosmic dance of life and death on a stellar scale as we anticipate the eventual supernova of Betelgeuse. It also prompts us to reflect on our understanding of the universe and the transient nature of the stars. Each star, no matter how mighty, follows a path that leads to its eventual demise, and Betelgeuse is no exception. This impending explosion offers an extraordinary opportunity for scientists to observe the end of a star's life cycle up close and study the intricate processes that govern stellar evolution. The data gleaned from this event could offer new insights into the behavior of massive stars, their internal structure, and how they reach the explosive climax that defines a supernova. One of the most fascinating aspects of this impending supernova is the opportunity to witness the diversity of stellar deaths. While Betelgeuse's demise will occur through a Type II supernova, there are other ways in which stars meet their end. Some stars end their lives as white dwarfs, slowly cooling and fading over billions of years, while others, much larger, collapse into black holes, their gravitational pull so strong that not even light can escape. The different paths that stars take to their deaths underscore the complexity of the cosmos and the range of phenomena that can occur throughout a star's life. In the case of Betelgeuse, the supernova explosion will not only mark the end of a massive star, but will also enrich the surrounding interstellar medium with heavy elements, including iron, calcium, and oxygen, elements that are essential for the formation of new stars, planets, and even life itself. These elements are forged in the cores of massive stars and are expelled into space during the supernova explosion, where they mix with the interstellar gas, eventually contributing to the creation of future generations of stars and planetary systems.